Hello, everybody. So in this session, we're going to continue with the numerical examples of uh, calculating the value at risk and expected shortfall using the example. Okay, so we have defined the expected shortfall in for student T, which is this equation, and under the normality assumption, isn't it? So which is this in this form. So now we're going to have one scenario that um, try to explain both of these example in a numerical way. Right? So let's say we have an example. Okay, so we have an example. Okay, so we have a portfolio. Let's say $10 million. Well, just an example. Okay, if I have $10 million, then most probably you go for retirement. So let's say we have 1 day returns. Okay, 1 day return. So it is normal student T, following student T distribution. Student T. Let's say the degree of freedom is 5. Okay? Degree of freedom 5. So the mean return, most probably what we have seen in most of the example, uh, this is your return, isn't it? And then this value will be close to 0, so which is the mean. So in this case, we just assume that for simplicity. So even it's non-zero, it should be close to 0, positive or negative. So you have a 0% for the returns. So for volatility, so you can use the return series, then calculate the standard deviation. So that will representing the volatility. Let's say 5%, 2%, and then the market is a bit stable this day, 2%. And then we want to study the left tail, 5%, okay? So in order to find out the compute, first we compute the VAR, okay? Compute, let's say 95% VAR, or 5% VAR, okay? So this is 95% VAR. The first of all, the quantile Q, according to the student T, the Q will be, you just find the inverse value. So this will give you the T value, okay, at 0.5%, okay? So this will be close to minus 2.015, okay, which is somewhere around here, 5%. So it's a negative minus 2.15. So the VAR in returns, the VAR quanta, okay? So quanta of VAR, this is mu plus sigma Z or sigma Q, isn't it? Under the student T assumption. So this is 0 plus sigma will be volatility 2%, 0.02 times minus 2.015. Okay, so this will provide us with a negative value, which is the loss. Value at risk basically is the loss. Okay, so in terms of money, the VAR at Q, which is 5%, is minus 0.0403 times the amount of money, which is 10 million. So this will give us the loss. So negative representing the loss. Okay? 403,000. that will be the worst loss for the next day, okay, with 95% confidence. So the 5% chance for your portfolio to lose more than $403,000 in one day. Okay, so this is under the VAR calculation. So if you want to calculate the expected value, compare this with expected value. Let's say this is the first one. So number 2 is the expected value, ES. Okay, so we know that now ES is actually the mu minus the sigma. Mu plus Q squared. And this is a formula we have derived earlier. So this is a PDF. We degree of freedom mu, the amount of Q, or the percentage. So just now we already found that the Q basically is minus 2.015. This is the quanta. Alpha, let's say, is 5%. The tail area, the PDF. So your FT5, so the Q basically will equals the value of FT. So our T value is minus 2 point. So you can use the table to find out the probability will be close to 0.065. Okay? 0.065. So this will be the value involved. So we just plug in the ES here. 0.05, which is the Q. So you have 0 minus the volatility. So volatility is 2%, isn't it? It's 2%, then times. So the formula will be, or you didn't write down the formula. So you have a mu minus, mu is 5, right? 5 minus, or minus plus the T value, minus 2.015 squared over. So this mu minus 1, 5 minus 1, alpha is 0.05. Okay, so times the FTS. So this equation basically, right? So we just refer to, or we just refer to this equation instead. Isn't it this one? So just substitute all the value inside. This is 0.065. So at the end, you should get, sorry, this is not, I think I make a mistake here. So this is 0 multiplied. 0 multiplied. The whole term is, okay? So this time I'm using this laptop to do the analysis, the calculation. So the value will be close to minus. Well, this is, we can just write 0 point or minus 0.02 times 2.94. So this will be close to minus 0.05. Okay, so this value representing the, so after that your ES times, of course this one is a quantile actually, okay? This is a quantile. So this is the ES is the value. So this is the quantile. This is the value of ES. So we just multiply the $10 million, is it? So this is 589,000. Okay. So if you compare this value, which is ES, and the value at risk, it means the value at risk. Okay, here. So we found that the ES is always larger than the value at risk. Okay, so because the expected value we are looking for is always, for example, you have this value here. So the value at risk is always at this position. If let's say your var Q is here, then your ESQ will be always smaller than this. Okay, for the left hand. Okay, if you long a position, right? So ES should be always smaller than value at risk because it's taking the average value. Average value. Use another card. So ES should be always smaller than var Q. Okay, so this will be the characteristic of value at risk and expected shortfall. A very simple numerical examples. Okay, so we'll end this session with this. The whole session basically is find out the expected shortfall after we determine the value. Okay, guys. Okay, bye. Thank you very much to be with me at the end of this session. Bye bye.